Hi, everyone. I'm the co-founder and chief scientist of NumberStation. Prior to NumberStation, I was doing a PhD at Stanford with Chris Ray and some of the Snorkel folks, actually. And today I'll talk about NumberStation, the problem we're solving, the solution we're offering. I'll do a technical deep dive into the NumberStation tech, covering things like LLM agents and RAG. And I'll give you a live demo at the very end of some of the agents that we built. Okay, so the problem we're solving at NumberStation is essentially analytics. So in the past decade, we've seen many enterprises invest in setting up a modern data stack. And while this is great on many aspects, like ETL pipelines, improving storage and compute, it has also caused a lot of issues, especially for data analytics teams. And the reason is there's a lot of complexity in the tools and resources that these teams use. And so ultimately they're overwhelmed with tickets from end business users or even like business analysts that try to consume this data. And so they ask things like, where can I find this dashboard? How was this field created in a database? Can you help me write this query? And many more requests like this. And so ultimately, these data teams spend most of their time actually in support functions of these end users instead of investing in longer term data projects that can truly impact the business. So with the recent development of LLMs, this problem is actually getting even worse. Everyone has seen all these amazing demos of LLMs writing code and SQL. And so the expectations from end users and leadership have risen to the next level. But in reality, we've seen many of these demos fail when it comes to production. And this is adding even more pressure on these data teams. So just for NumberStation overview, at a high level, we've spent a lot of work in the past decade on solving problems at the intersection of data and especially structured data and LLMs, both in the Stanford AI lab, where a lot of our team comes from, and enterprises like Elation and ThoughtSpot. And so we're developing a platform to help relieve the pressure that I was mentioning on these data teams and really bring the AI experience that people expect. And so one example customer is Vouch, an insurtech company that grew really quickly recently, and their data teams were just getting overwhelmed with ad hoc requests from business users. And so we help them self-serve a lot of these requests, and I'll walk through an example in this talk. Okay, so to give you a quick overview of how this looks, we have the following pieces. So we start by connecting to all the tools used in your modern data stack, things like the data warehouse, dashboarding tools, data catalogs, and even more things that may contain any knowledge related to data, things like Slack history for the data channels and things like that. We then automatically create what we call the knowledge layer, which captures a lot of the knowledge stored in these tools. So things like table definitions, popular calculation, documentation, and many more. Once we have that knowledge layer, we created a retrieval module, which is essentially RAG module that allows us to get context on many different aspects of the data for a given input question. So for instance, let's say someone is asking about conversion rates. Our retrieval module can get all the reports, tables and metrics that relate to conversion rates. And the last piece is the AI multi-agent framework, which is highly customizable and can interact with many of the tools that this organization use. So the original dashboards that they had, or like the data warehouse to run queries, etc. Cool. And so ultimately, organizations can build multi-agent systems that their end users can interact with. So just to give you an example flow, a user can come and ask for a specific dashboard. We'll use RAG on top of the knowledge layer I was mentioning to get the best dashboard. If the dashboard doesn't exactly satisfy their need, then they can use the analytics agent to write and execute a SQL query in the original data warehouse. And if they're happy with the results, they can create custom tool agents like Slack integrations or even like Gmail integrations to share back the results with their team. And this is just one example, simple flow. It's highly customizable based on the organization's needs. So just to implement this in practice, there's key 3 steps. The first really is to create this fundamental piece that we call the knowledge layer. And that's the layer that's used in RAG that stores all the business context that we need for the model's responses. So it stores things like tables, columns, metrics, dimensions, report, documentation about all these things. And that's really a key component of our platform. To create this, we built parsing models that connect to tools like Tableau, the data warehouse, and dbt, and automatically will curate that knowledge piece into a clean format that serves as the foundation of these LLMs. The next step is to configure what we call the base agents, which are used for search and analytics to build a workflow. So depending on the capabilities that you would want to serve to your end users, you can start composing agents that will talk to each other. And so, for instance, you could configure agents to search over Tableau reports and dbt documentation, and then add another descriptive analytics agents to write Python or SQL queries. And the last piece is this custom tool agent based on the specific end user workflow that we're looking at. So for instance, we had a customer create a Zendesk agent that their customers can use to create tickets when they cannot still find the answer through chat. And we can also do things like send emails or create a slide deck from NumberStation. So really here, anything that can be done through API calls is in scope here because that can be prompted in the model. And ultimately, you can embed these agents in existing applications, things like Slackbot, or we have also a front end, but usually people prefer to embed where the users already interact. Cool, and so just to recap the NumberStation intro, we're really helping address the key challenges that these data teams face, whether it's internally or even externally for analytics companies that serve dashboards to their customers, by providing a unified and accessible and actionable approach to analytics. So unified in the sense that it's unifying knowledge across different knowledge sources, accessible in the sense that more business users can now query SQL or write pandas code, and actionable because we're really trying to complete the end user workflow with these custom tool agents that I was referring to. Cool. So this wraps the intro. I want to jump to the fun part now, which is the technical deep dive. And I'm going to show you how to build a multi-agent system from the beginning. So I'm going to focus on one of our analytics agent, which essentially writes and runs SQL queries to answer business questions. And let's say I wanted to build such a system from scratch. The obvious first thing to try is prompting an LLM with few-shot or zero-shot learning. So I'll create a prompt with an instruction. Hi, can you write some SQL for me to answer this question? We can put in the data schema just so the model has a bit more context on the database. And the model is going to take this prompt, write a SQL query. I can then go copy this query into my SQL editor and get a response. And this is a good start, but there's obviously limitation with this approach because the LLM cannot execute the query. So this manual workflow of me copy pasting is not ideal. And so how can we do better? So an improvement to the previous workflow is just to add a SQL execution tool in our pipeline. So after the model generates SQL, we can automatically send that in an editor with an API and call the SQL API to get the result for the SQL execution. And so the naive way to implement this is really just writing code that implements this control flow. It's better than me going and manually copy pasting the result, but it's obviously still pretty limited because let's say, for instance, we had a compilation error. The model used the wrong table name. Well, with this flow, there's really not much we can do and we're stuck in this case. We could start adding edge cases in the control flow of if you hit a compilation error, then go back to the first step, but it just quickly gets very complicated. And so how can we do better than this? And that's where agents come in. So we talk about agentic systems where essentially the control flow of the operations we're running is not set by a human or a developer, but really by a machine. And we talk about LLM agents when the machine here is the LLM. So instead of running the query each time it's generated by the model, we can use something called tool calling, where really the model intelligently decides when to call a tool and when to run the query. So here, for instance, this is just an illustrative example, but the sequence of steps that the model would take is non-deterministic. It will try to find the best path and course of actions to get to the final result. So first it writes some SQL, executes it, sees that there's this compilation error. So based on this message, it's going to go and correct to get the right table name. Then it can actually execute and terminate this flow. So that's much better. But let's say the user was expecting something in the order of 1,000 or 2,000. How do we know that this is correct? And that's the key piece that's missing here is accuracy. We really want the predictions of the model to be grounded in something that belongs to the business. And right now, the metric that it generated we have no clue if it's correct or not. The model just made the best guess based on the schema that it saw. So the key to this accuracy problem is RAG, and Snorkel has done a lot of work on that front, which essentially stands for retrieval augmented generation. And essentially we need to use RAG because there's so much knowledge in organization that we can't fit all of it in the LLM prompt. So we're gonna store it and then retrieve it based on the question that the user is asking. And so in the context of number station specifically, the source we're searching over is this knowledge layer that I was mentioning, which stores information extracted from the data warehouse, dashboard, or documentation. And so here an example that I would have in my knowledge layer could be a metric definition for the number of customers. So it has the SQL expression and the table that this metric is calculated on. And if you see here, in the specific example, it has a filter to filter out customers that have their account closed. And that type of logic cannot be inferred by the model out of the box. That's why we really need to have this RAG component to make the model aware of the business rules. Okay, and so we can then just add RAG as another tool for our agents, and it can call it when it thinks that it needs it. So for instance, here, the updated flow for our LLM agent would be to first retrieve the context, get the definition for what we mean by number of customers, then generate the SQL, run it, and now we get actually the response that's aligned with the user's expectation. So in terms of just evaluating this approach compared to vanilla LLM prompting, we saw huge improvements on real benchmarks from our customers, up to 10 to 20 points in execution accuracy. So this is really great and much better. But if we take a step back and recall some of the things I was mentioning earlier, we really want the agents to do more than just write SQL, right? Like users may want to find a dashboard and do many other things. So how can we do all these different things in one flow that gets really complicated with one agent? And so to do that, we can start implementing a multi-agent system. So if a user wants to find a report, understand a field in a table, write a query, we can bring all these functionalities through a multi-agent system. And essentially all these agents will have a specific role in the workflow, and they can talk to each other through a chat manager or really like a router agent that is responsible for saying, it's your turn to talk and solve the task. And what's really exciting is all these agents can share the same conversation history. So it makes it really easy to jump from one agent to another, but they can also collaborate to solve the task together. And so we can start building very powerful applications. Cool. So I'm getting next to the end of the deep dive. The last bit I wanted to cover is the connection between unstructured data and structured data, especially focusing on Snorkel. And so everything I've covered so far lives in the analytics world, which is mostly structured or semi-structured. But there's tons of knowledge also stored in unstructured sources like a document store, and we may want to query that as part of the analytics workflow. So how can we do that? There's two options. Option one is when the schema of the unstructured data is well defined. So let's say we have a bunch of quotes, documents that are PDF documents, but really they have the same information every time, like customer name, policy ID, quote amount, etc. So in that case, we can use a document extraction flow from Snorkel to transform the data into a structured table in the database. And then we can start querying that table with number stations. So for instance, here, if I want to know the average quote price for my healthcare company, that's the sort of question that really lives in the structured world. And once the document extraction is done, we can just run that query over a database. There are other more complex scenarios when the schema is not really so clear. So for instance, let's say there are specific clauses mentioned in my quote that are not always present. Not all customers have them. It's like in unstructured text. And so if I was trying to extract that into a structured format, I'll very easily lose a lot of information. So I actually want to keep that unstructured content, but I want to also be able to reason over it during my analytics workflow. So the way to combine this type of two sources is through a multi-agent framework where we can have a text-to-SQL agent interacting with a database, as Shane was mentioning, and a document agent that is going to be interacting with the unstructured data and document store through RAG. So just an example workflow here, let's say someone is asking about a specific customer, and if any of their contracts mentions flood coverage, Well, the first thing I could do is ask the text-to-SQL agent to give me the contract IDs for that customer that's very structured and lives in a database. And once we have those contract IDs, we can go over the document store and look for the clause that's mentioning flood damage, which is very unstructured and hard to store in a structured data. So that's pretty much it for the deep dive. I'm going to show you a quick demo of these agents in action, in particular, a small Streamlit app that we built for demo purposes on top of our agents. And really, you can think of it as the APIs that power this app. In general, customers like to store, like to use the front end that they have already, like embedding the app in Slack or something like that. So I'm going to show an ad performance example. And in this demo, we have a multi-agent system with two agents talking to each other. And in particular, I'm focusing on analytics agents. One is responsible for descriptive analytics, so really answering what type of questions, like what was this metric over that quarter and things like that. And the other is more a diagnostic agent for like drilling down into specific patterns. So I can start by saying monthly conversions in 2023. So this will route my descriptive assistant because this question is pretty precise. Like I know what I'm looking for, and it's going to give me the performance of all my ads for 2023. And let's say I actually want to visualize it, so I can say plot it. And this is going to go and update the code to give me a chart. One thing to note here is this is Python code and working over CSV. In enterprise use cases, usually we use SQL and actually run the queries on the database, but just for demo purposes here, CSV is fine. So it gave me a chart, which is good, and it has a downward trend. So let's say, for instance, I wanted to have a bar chart. I can ask it to update that. And I can also do things like change the color, the font, etc. But I'm not going to get into those details. But it's really interactive and users can customize. So now I have my bar chart with this downward trend. And I'm still in the descriptive analytics world, like analyzing specific KPIs. But now I actually want to understand why is this going down. And so I can ask it, explain the downward trend. And so I would expect this to be routed to my diagnostic agent, which is responsible for like those drill downs and trying to understand what's happening in the data. So the diagnostic agent is gonna look at diagnostic analysis, and it's gonna start looking at the company type. So this financial company we're looking at is putting ad across different channels and different companies. And so it's starting to look at the company type. It tells me, okay, by company type, we see that there is a clear decline for companies, events online, the thing is really steady. And so we see that there's a downward trend from January to December. The models we use in the backend are multimodal, so they can actually read the chart and summarize it, which is really cool. And so then it's going to do another level of drill down. And what's exciting is I didn't tell it to do this other level. It's just by itself said, okay, I'm onto something here. Let me look further. So to further diagnose, we can drill down into the company subcategory. And so it's going to look at the subcategory. And now we see that Silicon Valley Bank has a very significant drop for the drill down, which actually makes sense. The company had a big financial crisis last year. And so it summarizes all of this information, very high number of conversions from January and February, and then a sharp decline, which remains. So it thinks that this is what explained the drop. Would you like to investigate further? No, thanks. And again, for demo purposes, we're putting the agent names here so that you can get a sense of what happens in the background. So here it's routing back to my general assistant, which is there really for like the management of the chat and routing between agents.